Okay, so don't break GraphQL extended, which I also summarize in a very takeaway sentence for you, which is being kind never hurts. That's it. Even when you're just dealing with standards, remember this. Once again, I'm Paolo. Nice to meet you all. I'm a DX engineer, staff DX engineer at Nearform. I am also a Node Core member. And quiz for the audience, if you don't know my bio, where do I come from? Which city? Go for the city. Good one. Finally, thank you very much. Okay. You can find me online on all those handles over there, especially my website, which I just redesigned, so please review it. I'm just curious of how my graphical ability, like Eduardo was saying, if are better than his or not, so I want feedbacks on that. And now, let's get to the meat. Almost. I want to also talk about the Nearform, which is the company that has sent me here today. We are a professional services company, fully remote based, 300, actually much more now, and counting people. And we are always looking for new talents. Once again, fully remote. If you're interested, just say hi to me after this talk. Also, if you're using JavaScript, it's better to say hi to me because you cannot escape from us. We have 8% of NPM modules and we $1 billion per month. So behave with us. Just saying. Anyway, keep moving. So I've seen quite a lot of people in the audience that are using GraphQL in production. Why is that? Because it's just great. It enabled us to do very, very nice things with minimal effort and made our life much easier. Now, people that have spoken to me earlier, they say that now I think that nowadays developers are a little more spoiled than our seasoned developers because life is much easier nowadays, right? I mean, you have more choices, but you have much easier choice to make, right? And GraphQL, it was revolutionary on the backend side because several reasons. For instance, you can ask for many resources which much less overhead and with just an expressive language. You don't have to make up your language every time you create a new backend. For instance, you can ask for multiple resources from different endpoints, tables, services, domains, you name it, domains, whatever you want to name it, with just one request, so you save network bandwidth. And we all know how the TCP connection is expensive if you're interested in network performance. For the same reason, there is no overfetching and no underfetching of the resources, because GraphQL, I think it was the first protocol and the first query language that actually stated that is the client that determines which selection of data is actually returned in the API. REST usually doesn't do that. gRPC does, but it's a completely different beast. When you're just talking about general API querying languages, this is probably the first one, or one of the first, because let's do the conditional, because otherwise somebody will argue. But anyway, the one thing that also was very important for GraphQL was the federation that we will see in details in a bit. Federation is just a way, a defined way to compose several services that must not be on the same on the same network, on the same machines, networks, availability zone, regions, can be anywhere. So you can split your area of concern in your application anyhow you want. And that's fine, it works just fine. There is just one little limitation. That's only for splitting GraphQL in many GraphQL, which in general, it just works fine. But sometimes, if you want to integrate, for instance, with the existing REST API and you want to use federation, you have to write some sort of compatibility layer by hand on your side, which sometimes might not be ideal eventually. Might be fine, might be not, depends on who is going to write it. But in theory, I don't know. It's less than ideal because different teams on your organization must be able to handle different technologies at the same time, which is not always the case. There is also another nice thing about GraphQL, which is the serialization. If you read the GraphQL spec, and we will get back into this in a lot in the rest of this talk, GraphQL does not enforce any serialization format. You are free to use anything. In theory, you could use messenger pigeons and it would be just fine for GraphQL. It would be still compliant to GraphQL. Now, I bet you to try to measure the latency of this kind of serialization format and transport format, whatever. Anyways, same, serialization, network transfer, you can do GraphQL via UDP. Yes, of course you can if you want. So you can do anything. Now, since I like to make up completely random numbers, 99% of GraphQL, completely made up, just in case, is JSON over HTTP. Why is that? Because it's broadly used in any language. I think that any language you can possibly use today has a JSON package, crate, whatever you want to name it. And if your language does not have JSON available in any way, run away. Just run away. Drop it and run away. It's probably either bad language or maybe eventually just a young language, so you can reevaluate later. But in theory, JSON is so broadly used that it's now like not having HTTP or not having TCP in a programming language or any available package for this language. Now, let's think about when you are extending GraphQL. So, usually how it works. You create a new GraphQL service. You define your types, which also includes your query and mutation. You define some selection set on each of these query and mutation. That's fine, you deploy your service. And this was the MVP, the minimal viable product, right? So now you have to add new stuff. And here comes the problem. It might be, if your organization is big enough that front-end and back-end are completely split team, that the server is advancing much faster than the front end, because usually the new data is added and collected on the server first and then broadcasted to the client, which means that, how you can read behind me, the server knows it better. In this case, how do you push additional data for a client that has not asked for this data because it just doesn't know that this data even exists before the client gets updated as well? Remember that one thing that I said at the very beginning was that GraphQL has no overfetching. The server cannot push additional data. So the idea is, how can the server be proactive here? How can we do that? What now, basically? We have the APIs. We control everything in the world, right? So we follow the just standard flow. We add new data to the server schema. Of course, in that case, you have to make sure that they don't collide with any existing query, type, mutation, field, or whatever. Otherwise, you have a big issue, especially if you are changing the type. Or actually, even better, if you're not changing the type, but you're changing the meaning of the field. For instance, a number now gets a completely different meaning. You might break clients, right? So the second step is, of course, make sure that the clients are still working when they just ask for the old data, which is mixed with the new data, because some things like that might happen. And then in the third step, update the clients. So basically, the clients are either you change their UI, you change their services, and basically you ask for the new data. And we're done. So did I take a 5-hour strain just to say these things to you? You know, or of course not, because there is one big flaw in all this flow of stuff, is that the APIs is mostly theoretical. If you are a pragmatic person, you know that you actually don't control anything in your life. Even things that you think you control, you don't actually, right? So the biggest issue here is not on the server side, because on the server side you have a very good control on the server, kinda. But you don't control the client at all. First of all, let's assume, and we're gonna see this thing later. The first step I'm gonna come back later. But let's assume that everyone is updating, right? If you fail to update all the parts of the client that you need to update, you have compatibility problem. And any compatibility problem at this stage on the client is perceived by the user, and depending on how bad your user is, they might never come back to your application. So you lose money, people get mad, people get fired, mortgages are broken, and so forth, right? Anything horrible can happen. Now, if you instead also can enforce, this actually, the idea here is that I'm assuming that something goes wrong because you can force the clients to update, which is never the case. Now, raise your hand if you don't usually update your application often on your phones, please. There must be somebody here. Well, that's one, just one. That's two, right? That's three. Many people in my family do the same thing. They never update their applications. So if you basically cut them out, they will complain. Why these people all of a sudden they don't support the application anymore? I still want to use their application. Think about WhatsApp, for instance, when they cut out very, very old hardware, right? What happens then? They are unhappy, they switch to Telegram in this specific case, and they will never get back to your application. Why? Because you force for fancy new stuff that they haven't asked for, and you force them to update. It's perceived as bad because they don't want to be forced. In some other technologies, you might automatically upgrade. Think about service worker. But of course, the Murphy law states that you will refresh the application while the user are using that, and they will piece as well. So you can never win. You always lose. Of course, there is a third option. You can send the new data even for clients that haven't asked for this data, and you're breaking the specification. Simply put, in this case, you are breaking the specification. Remember after me, never do this thing. Never break GraphQL or any specification. Side note, I maintain the HTTP parser for Node, and I want literally to chase down people that have coded several hardware devices that have a faulty HTTP implementation. Due to those faulty HTTP implementation, there are security implications in Node, and I cannot cut them down, otherwise I cut out these devices. Because why is that? Because they broke the specification. In this case, hardware is very hard to fix, right? Because you cannot physically get to people. But in GraphQL, which is probably a little more lenient, it's still a bad idea. Now, why is a bad idea, first of all, before getting to if we have a choice or not? The bad idea comes from the fact that if you break the specification, there are obviously just two possibilities. Client will be fine with that, and client will complain. If they complain, once again, we go back to the previous idea that you make your clients unhappy. On the other side, if the clients are now happy with that for any reason, they might not be in the future if any depending component is updated. And once again, at some point, you will get a bug that you don't relate to your update because time has passed, because you don't remember when you actually break the specification, and clients are still unhappy. So we always get to the same point that you make your customer unhappy, which is pretty bad idea if you're willing to take their money, right? So don't do that. Once again, do we have a choice? Of course, I wouldn't come here to Verona if I don't have a solution for you, right? So we do have a solution, or at least one of the possible solution. In my case, the solution that I'm about to show you is something that I actually implemented for a client several years ago in Nearform for a problem like the one that I'm going to show you. So the client wanted to add some fields that were highly mutable, so you can't really predict or write a query for that because they were changing all the times, and send it to the client that they was not aware that this data might change at any time. Think about the mess of using GraphQL in a situation like that. Because one of the perks of GraphQL is that you have a regular and inspectable query object system, and you just basically remove this basic idea for GraphQL. But they had to do for GraphQL because they already had GraphQL implemented everywhere in the org. So, do we have a solution? Yes, why not? Let's make an enriching proxy. Pretty much it. Of course, you have to figure like that very St. Bernard dog, of course, which is fluffy as hell. But the enriching proxy might save your life. It's a pretty simple idea. I mean, the idea, don't look too much at the implementation that I'm going to show you, but you get the idea on how you can be creative and think outside of the box in order to expand the protocol without breaking it. int. This was the Turk's title, right? First of all, I leave you this slide for a couple of seconds. If you want to take a look, all the code that I'm going to show you today, you can find it online on GitHub if you want to take a look. It's the entire example that I'm going to show you. Few more helper methods, but that's pretty how it looks. This code that I'm about to show you uses the reference GraphQL implementation for JavaScript. So you get many of the stuff you need for implementing something like that, basically for free. And you always sure that are official because they are just the reference for JavaScript. First of all, let's see how it works. That's pretty simple. First, you have to analyze the query that the client is making. Then, for a reason that I will explain later, so bear with me on that, trust me on that, you have to make sure that each level of your query or mutation has type information associated. The reason will be clear later. You execute the query on the original upstream server that the client was meant to reach, which can be or cannot be under your control, so it can be anywhere. Then, using a tree traversal algorithm, you fetch the additional data that you want to inject at any level. And finally, you inject this data. Do you see anything wrong with what I've just said? Amazing. So I've said inject the data, but I'm not going to inject the data in a breaking way, obviously. Otherwise, my entire speech is basically BS. I'm not going to do that. There is a way to inject this data without breaking the specification, which is the core idea. And as you can see on the subtitle there, the additional data is stored in the extensions field using JSON path selector as the keys. Little quick poll. Who knows about extensions field in JavaScript, in GraphQL, sorry? Raise your hand. Just one. Wow. Okay, that's fine, no worries. Who knows about JSON path technology? On this one, I'm going to blow your mind because you actually know about it. You know about JSON path. You just don't realize that, but trust me on that. Let's check it out. First of all, GraphQL extensions. Now, what is the typical structure on a GraphQL response? What are the top level fields? Anyone? Shout out. Come on, Tejas, go for it. No, that's the request. About the response fields. And then? Okay, there is a third one. There is the extensions. The extensions actually is one of the less used fields because it's completely unrelated to the data, right? It's not usually used in the data because it does not carry any information on the data that was originally asked for the client. And actually the client has no idea that the server might eventually what the server might eventually send in the extensions field. If you read the GraphQL documentation, it specifically says that extensions are left for the developer to use as they see fit. So they're not meant to be analyzed with the data, and they can contain just anything you want to put inside it. Pretty much, right? Think about an attachment for an email to give you some ideas. It's not part of the email text, and it can be just anything. And the fun fact is that since they are free to use and a client must specifically parse it outside of GraphQL handling, existing client will just ignore that. You can easily see how using extensions will allow us to send data to the client without affecting existing client. They will just ignore this field. And that's this one is the overview of the algorithm that I showed you earlier. This is the entire endpoint. Is anybody familiar with GraphQL in JavaScript? The technologies that the server technologies that can be used? Okay. So one thing that I want to remark there is that first of all, on line 2, I use the reference GraphQL implementation like I told you earlier. So I just include GraphQL language index. Then on line 7 to 17, I implement the 5 steps that I showed you earlier that we'll get back in a bit. Two important things to remark here. First of all, the very last line, when I return data to the client, I have to remember to merge my extensions with the upstream extensions. Otherwise, I might remove some important data. That's a stupid thing to remember, but remember that if I don't break this thing, that you don't have to break since you are acting as a proxy, you have to return first whatever you got from the server, and after some data that you want to add. The server upstream always comes first. The other thing that I also want to remark is that in the JavaScript world, usually the most used JavaScript GraphQL server are Apollo or Mercurius. Do you see any of those in that code? Any import of Mercurius or any import of Apollo? Because that's the complete endpoint. And that's the thing. In order to, since I'm using the GraphQL implementation reference, I don't even have to start a GraphQL server locally. I can just parse the query and forward it without even executing and analyzing locally, which is pretty neat. My only dependency for this project were Fastify and just because I don't use Express. Side note, don't use Express. Don't, folks. There is a huge maintainability problem on Express. It's using very old libraries, don't do that. Fastify, happy, Koa probably less, but eventually might be better alternative. Fastify first, I love it. I love its creator and many of its maintained by former colleagues and friends and so forth, so I'm a lot biased, so Fastify is the best. Otherwise, happy is also good, and then there are many others. Just do me a favor, don't use Express. Otherwise, at some point in Node, we're gonna break the compatibility and you're screwed. If you complain later, we're just gonna ignore you because the last time some dependency for Express were released were 8 years ago. So it's probably time to update, right? Anyway, move on. Earlier, I told you that we have to make sure that we add types at any level. The reason for this is that what we are basically implementing with this proxy idea is a rules engine. And one of the easiest rules to implement in GraphQL is just to look at the type of selection set that you're actually receiving. So basically, we make sure that at any level in the, let me try this thing, at any level, there is a type name, either aliased by the original query, aliased by us, or just unaliased. Just for reference on the other side, of course, we are talking about line 3, line 6, line 9, or eventually 10. So at each selection set level, you need to know the type because later you're gonna use it for applying rules. Also, remember that these fields that you actually ask to the upstream server are temporary. While on line 3 and on line 9, those were part of the original query, the one on line 6 and line 10 were actually added by my proxy. So I have to make sure that I never return this query on to the client, otherwise, shut it out what I'm doing. Somebody please. Yes, that's the point. We never want to break the spec, so we have to remove it before getting back to the client. Now, how do we ensure that this type of information? The things that you need to notice is that despite of some oddities in the code that you don't really care about, the core idea is that if you look on line 13, I'm just using a visitor API given by the GraphQL spec, the GraphQL reference spec, And what I'm saying is that whenever you include in a selection set node, so basically when a selection set, I forgot to mention earlier, a selection set in a GraphQL query is where you specify the list of fields that you want to see in the response. That is called a selection set. So whenever you include in a selection set, I iterate all the selections in that set. I check if there is a type name. If it's there, I'm fine. If it's aliased, I actually add my own alias because it's easier to track. I could have done it a different way, but bear with me that I was lazy, so I just went for adjust my specific ID so I can easily recognize whether I have to remove it or not from the response. I just unshift, which in JavaScript is the basically pop from the head of list, and that's it. And then I return the new document because as I'm using the visit API, I'm getting a new document. I just return it, and this document is the one that's sent to the server. One important thing here to remember, and this does not only apply to my proxy, but applies in general. If you're using Node and you, for any reason, parsing the query, a GraphQL query, remember to cache it even in memory. Even with list recently used cache, but cache it because parsing is expensive. As you all know, this is a CPU-intensive operation, and as you all know, Node does not like CPU-intensive operation because the event loop is blocked. So if you need to parse the queries for this proxy or for anything else, good advice, remember to cache it, both the input document and the output document. And finally, before we get to a final example that will basically allow you to have dinner, let me introduce two final friends. First of all, two missing concepts that I haven't introduced so far. First is the depth-first tree traversal. So, are you familiar with this concept? Can I just move on? Anybody which doesn't know about it? Okay, I just skip it since I have not much time left. But basically, this is the order in which basically in a depth-first tree traversal, you visit the tree. And the reason why I chose this one, because you don't have to use recursion, and it is very, very easy to... sorry, you have to use recursion, but you have to use it in a very simple way that is much easier to write in JavaScript. And now I'm going to blow your mind. Now tell me if you don't really know JSON path. You don't really actually use this syntax in JavaScript every day to access JSON objects. You do know, right? It's just JavaScript syntax. Of course, there is just a leading period, but it doesn't really matter. The thing is that this one is very powerful syntax. And once again, if you don't have in your language, you can easily implement. In this case, I'm not saying run away from this language, but you can easily implement it. And I will demonstrate that. And it is very, very simple. I mean, at least in the basic way. Specification to traverse JSON structures. If you actually look at the full JSON path specification, like they did for React, they've made very horrible things, make it overly complicated. But for basic stuff, works just fine. And now the shows just go on. First of all, we enrich the data. So what is the idea in order to enrich the data? Using the traverse operation on line 4, every time we get to a node, we execute receive handler, which will be responsible for fetching additional data somehow. And in the extensions field, using the JSON path, so I'm talking about line 18, we add the additional data. Pretty simple. So we traverse each node. On this node, we check if the handler can receive some data, and we send it back via the extensions field. The very important thing here, also never forget this thing, is the line 22. In the line 22, we remove the type information. So the enriched ID is the type, the unique field that we use for typing. We remove it on line 22. Side note, do not use the delete operator in JavaScript. It will make your object very slow due to something. You can search it online, I don't want to side note, but general advice, if you want to serialize JSON and you have to remove a property from an object, set it to undefined rather than use the delete operator, because it will be painfully slow, will kill your performance. Now, the traverse operator, which is the depth first traversal, whatever, if you look at how it's implemented, I don't want to look at it now, but this is actually an implementation of JSON path. I'm not using any pre-made JSON path implementation. I implemented it from scratch. As you can see, if you look on GitHub, it's pretty easy to do that. You just have to do for loop on entries, on keys, check if it's an array on an object, and I want to say thanks to JavaScript typing for this horrible stuff. Because remember, the type of an array is object. For some reason, I will never understand even after 10 years. But whatever, and you recurse, and that's it. Not very hard to implement. Now, this is the core of the rule engines that we're implementing. This function receives a type, a JSON path, and a value of this current selection set. At the very beginning, we check if the type is city, is not city, we don't do anything. That's why we add types everywhere. We say, if it is a city, I know that I want to fetch some data, otherwise I don't care. In this case, I'm using undici, which was actually the third and only dependency I forgot, to fetch the additional data from another server, and I add it to the response. Notice that that server is not a GraphQL server, it's a REST API, which means that in this case, we can mix REST and whatever you want. REST, gRPC, TRPC, whatever you name it. Once again, Messenger Pigeon if you want to wait a very long time, whatever, works fine. Finally, no more code, just an example. After the example, I will ask you if you actually understood this, because, okay, let's do that. This is the input query. Pretty easy, right? So in this case, we have a country, and we get the name and its cities. The city is then implemented using edge and node, and you can see that we have type name only on the cities and on the very top level, but using an alias, which is bad for us. Then, second step, after we validate the query, we add the types. What they become? This thing. So you can easily spot that I'm using the same identifier at any level, so I can easily spot it later to remove it. So I added the type at any level that it was actually missing a type. Pretty easy, right? And this is the query that is actually sent to the upstream server. So the server that you don't even actually control, you have no idea how it's actually implemented, you send that, that query. And then you receive a response. This response, you can easily spot what were the value for the fields that I actually added. So line 3, 5, 12, 14, 19, and 21. And these types will be removed from the final response. Finally, we get to the final, like when you actually name designs and documents and so forth, right? So we get response.final.json. That's the data field. So you have countries, you have alias, type, name, whatever, or everything, right? And you can easily see that it completely corresponds to this one, the original query, right? But as you can see, there is line 24, and there is the comment out, because that's the next session, which is, that is the additional data. Now, if you are the client, you can easily see from the JSON path, you can easily see, okay, that was from, for instance, for the city of Abbeville, the temperature was 0.5 degrees, because you can easily relate. While, for instance, you see that for edge number 1, you could not get the temperature, and the remote service returned an error. That's it. That's the entire idea, which is quite called mission completed. That was it. Now, once you get the example, raise your hand. Was that hard? Once you get to the example, because I can see the code might be misleading. But was that very hard to follow? You got everything then? Okay. Honest reply, finally. Okay. But pretty much that was the idea. I could have done probably something simpler, maybe. But the idea was that I can show you that I showed you how you can actually manipulate a query, do whatever you need, and return data in a compatible way, or kind ways. That's why I say being kind never hurts, right? You can be kind and still allow for your evolution. So you don't have to stagnate your application because clients are not updating that. Just find a different way to do that. Simple and neat. Now, what we can learn from this long journey? First of all, you're gonna hate me for this, but read the F specification, please. Because usually they already contain what you're looking for. The client I spoke at the very beginning didn't know about this thing, and I was already ready to break the possible compatibility in the world. And given that this was a very, very huge customer, it was be a colossal problem. So luckily, I stopped them, luckily. Also, as I already said, be compliant, because even lenient clients now might not be in the future, and once again, you might get into a compatibility issue. And finally, which is slightly beyond development, you don't control anything. You never control anything, not in development, nor in life, nor anywhere. If a thing can go wrong, it will go wrong. You remember Murphy's Law, right? And you remember people today, I don't want to name it, but you remember that, right? So you can't control anything. So be prepared to not control anything, and be defensive on that. That's called defensive programming for a reason. Finally, usually I close all my talks with a smart quote from somebody much smarter than me. That one is Douglas MacArthur, or I should say General Douglas MacArthur, was a World War II hero for the United States, and he says, "You remember for the rules you break." Now, reading that sentence, who reads that in a positive way? Raise your hand. Okay. Who reads that in a negative way? You see that, right? If you are an innovator like, I don't know, Steve Jobs, Musk, if you name it, or whatever you want to name it, they will remember you in history forever. If you break all clients during Christmas Eve, they will remember you as well. So beware. That said, I'm done. Thank you very much, folks.
Paolo, that was a great talk. Thank you so much.
Thank you very much.
Thank you so much. It's so relevant, so useful, and I'm a little bit ashamed that I didn't get the extensions.
Nobody used them actually.
I thought I knew GraphQL. Questions? Where this is the last talk. This is your last chance. Well, not really your last chance, because there's an after party if you want to ask him questions more personally.
Absolutely.
But any questions now? Jumping out at people quickly.
Over there.
Over there. Mike is coming to you. Is his name Mike?
I think it was Corrado, if I'm not mistaken.
It's working?
Yeah.
Awesome. Great talk. Thank you.
Thank you.
I'm just curious, at the very beginning, right? Before you came up with this idea of enriching the response through the use of the extensions, did you have any other ideas before that? How did you came up to that? Because for me, it was not obvious. I was trying to think about other solutions. I couldn't think of any. So it seems that it fit quite nicely. How did you reach there? What was the thought process?
That's exactly the point, because at the very beginning, the very, very short story of the request that was made was, we need to add new fields to some existing selection set. And I start working on that, because actually you just have to change the query annotation or whatever, right? The fact that this thing was actually coming from an external REST API was not really an issue, because I could just have write a remote resolver. But all of a sudden they drop me with a bomb and say, oh, we have no idea how the structure is going to be. So it was either I have to translate that mutating structure to something that the client can always understand, or for instance I can embed that structure serialized inside the query, but it just felt very ugly and very unelegant. So I checked, before I get through, let me see what the GraphQL spec allows me to do. I discovered about the extension, and don't ask me why I got in that crazy idea, because I also meet you that you have to handle fragments, unions. There are a lot of stuff that for your own mental health, I completely skipped in this talk. But there are the real project was way more complicated than this. So I actually regret my idea, but it's a good technique anyway, if you're not dealing with a very insane customer.
Thank you.
You're welcome.
More questions?
Anyone else?
Anyone else? Okay. If there's no more going once, going twice. Okay, there's no more questions. Thank you, Paolo.
Thank you very much.
Absolutely.
Thank you.
Fantastic.
Thank you again.
Fantastic.